Settlement areas are expanding worldwide and are concentrated in ever-growing cities. More and more people are sharing the available space on our planet. By 2050, around 9.7 billion inhabitants will live on Earth, of which more than 6.5 billion will be in urban centres. Today, only 3.5 billion live in cities. For many cities in recent years, the development of roads, tracks and bridges has not been able to keep pace with population and traffic growth. The southern entrance to Stockholm exists since 1871 from a two-track route. These tracks are used by pendeltåg, regional, long-distance and freight trains. The track has a maximum capacity of 24 trains per direction per hour, which is reached almost constantly. A further expansion of the local and regional public transport is therefore not possible. The most critical bottleneck results from the two-lane central bridge in the centre of Stockholm. On this bridge, traffic capacities could not be further developed. In 1854, the Swedish Parliament decided to build a national rail network. And by January 22, 1855, they had commissioned the Swedish rail pioneer, engineer Nils Ericsson, to take responsibility and carry out the planning and construction of the Swedish railway network. The Stockholm Central Station was opened on July 18, 1871, and initially had 5 tracks. Today, the station has 18 tracks. Stockholm Centralen is used by more than 400,000 passengers every day, in an ever-increasing trend. Of the daily 170,000 train passengers, there are about 105,000 commuters, mainly with the commuter trains and the pendeltåg, a kind of S-Bahn. Another 25,000 take the Arlanda Express to Stockholm Arlanda Airport. About 40,000 passengers use the long-distance connections. The subway station T-Centralen, which has been located below the station since 1957, is used by around 161,000 passengers daily. The trains are operated by Stockholm's Tunnelbanan. Today, 80% of Swedish long-distance railway connections start or end at Stockholm's Central Station. The groundbreaking Tunnelbanan project, which represents the solution to the problem of the bottleneck on the Central Bridge, took place on January 24, 2009. The new Tunnelbanan line runs 6 kilometers through a tunnel with 2 tracks. The tunnel starts at Tom de Border on the northern city limits of Stockholm next to the Karolinska Institute. Here the route branches off from the northern entrance to Stockholm Centralen. The tunnel then passes under Vasasstaden, Norrmalm, Ridar, Holmen, Söderström and Södermalm. It ends at the existing underground station of Stockholm Södra. The tunnel contains 2 tracks for pendeltåg. Station City is located at the lowest point of the tunnel, 40 meters underground, next to the main train station and below the station of Tunnelbanan. There are transfer possibilities to all lines of Tunnelbanan. The station has 2 middle platforms and 4 tracks. The station under the district Vasasstaden consists in the first stage of development of a middle platform with 2 tracks. This includes transfer possibilities to the Tunnelbanan and city buses. In terms of passenger numbers, the station has become the 2nd largest in Sweden, replacing the former Karlberg station. A 6-kilometer-long commuter train tunnel with 2 new stations at Odenplan and T-Centralen maintains double-track capacity for Stockholm City Line. For more safety and comfort, all platforms are equipped with platform screen doors, PSD. The scope of work for the PSD supplier includes design, production, installation, testing and commissioning, and 5 years maintenance of a complete platform screen doors wall system. The PSD components are customized for the platforms at City and Odenplan stations. The Platform Screen Door Central Interface Panel, PSC, represents the control and monitoring system. It is responsible for all PSD-related automation, control and monitoring functionality. All automated sliding doors, ASD, cabin access doors, CAD, and emergency exit doors, EED, are provided with a door control unit, DCU. These DCUs are located within the header box sections above each door. The purpose of each DCU is to provide the detailed level control for door operation and a central connection point for door sensors and actuators. There are 4 local control panels, PFA tablers, installed per platform edge, adjacent to each of the operation staff doors, CAD. The PFA tabler is connected with the PSC over both hardwired electrical signals and a data connection. The train positioning and guiding system helps the drivers to stop the train within the tolerance required to align the train doors and PSDs. This function is realized using a light board arrangement, giving dynamic distance indication to the train driver, together with fixed signboards. The Passenger Detection System, PDS, is a non-contact detection type system. The PDS is installed on the threshold along the platform edge to detect passengers being trapped in the gap. The PSD power supply is used as a centralized uninterruptible power supply system, UPS. In addition to the technical specifications, the PSD wall system has to fulfill the following special conditions. Out of an international tender evaluation, in July 2013, Gilgen was awarded to supply the PSD walls for City and Odenplan station. Such a complex project demands a multifunctional organization with experienced and highly motivated staff members. After the setup of the project organization, the project team immediately started work designing the system. The design phase was divided into 3 sub-phases. The main purpose of the innovation work phase was to further develop the technical requirements towards meeting the following overall goals. Effective opening and closing signaling for PSD. The system for the opening and closing of PSD doors incorporates both automatic control of the train's door movements as well as manual control by personnel. Effective support for positional stopping. The visual supporting system guides the train drivers to stop their trains at the right place on the platform within the required tolerance of ± 750 mm. Individual door opening. It is possible for each PSD door in the wall to be controlled individually when opening. Optimal door dimensions in terms of width and weight. Safety in the space between wall and train, in terms of physically preventing passengers from remaining in the space between the train and platform wall when the doors close. The outcome of the innovation work phase includes harmonized technical and ergonomic design requirements and specifications. After clarifying, modifying and adopting the original technical requirements with the outcome of the innovation work phase, the preliminary design phase then focused on the design, production and testing of prototypes for the PSD wall system, including its related subsystems. To meet the tight project schedule, design of the time-critical parts for the production needed to be finalized and ordered early during the preliminary design phase. The outcome of the preliminary design phase includes prototype installations for validation testing, test reports and required design optimization to meet the requirements in terms of cost-effective solutions, state-of-the-art design and technology, reliability, maintainability and safety of the PSD system and its related subsystems. The outcome of the detailed design phase includes the technical documentation for serial production, installation and maintenance of the complete PSD wall system and its related subsystems. Such as manufacturing and assembly drawings with associated work instructions and control plans for the production and layout and configuration plans for each station and platform. The start of serial production is based on the technical documentation, the supplier evaluation for special parts and subsystems, the quality and process control plan, and the factory acceptance test requirements. In the field of the production of screen elements and curtain walls, Gilgen utilizes its network of experienced partner companies. All different screen elements are built out of the same basic profiles made of aluminium and assembled on a production line customized for this project. Key component parts and sub-assemblies are manufactured in Switzerland and some of them in Europe, in compliance with the quality and process plan. Dimensions and functionality of the screen elements are 100% checked and recorded. Production and logistics processes are focused on the just-in-time principle, with production and deliveries from the logistics centres in Switzerland and from key supplier production sites directly to Stockholm to meet the tight schedule for the installation. It is of utmost importance that the principal elements of the PSD system can be efficiently and safely transported from the factory to the platform, and in addition that their storage requires only minimal space. Drive, control and monitoring systems for PSD doorways and emergency exit doors are manufactured, assembled and tested at the Gilgen factories in the district of Schwarzenberg. It is Gilgen's strategic policy to keep the know-how for PSD core systems in-house. A header box contains the complete drive and control system for one PSD doorway module. Before the shipment to Stockholm, all PSD drive and control systems have to pass a factory acceptance test, including a 2000 cycles test. The outcome of the production phase includes all serial manufactured, controlled and tested component parts and sub-assemblies for the PSD wall system and its related subsystems. The success of the installation phase depends for the most part on the quality of the logistics concept. This concept has been customized and set up to meet the requirements of the City Line project. The installation phase starts with the just-in-time delivery of the material from the Transshipment Center down to the platforms in City and Odenplan stations. The packaging is custom designed to handle and ship the material from the factory to the platform without any damages. The logistics process is focused and harmonized for the use of standardized handling equipment. Thanks to the modularity of the system, the PSD wall elements can be easily installed step by step, and tolerances of the civil engineering interface can be balanced. For the installation of a customized PSD wall system in line with a new construction project, all installation steps can be tailored to particular needs on site. The essential step includes the positioning and fixing of the mounting brackets for the structural elements. Each single bracket has to be aligned in reference to the track center line and the stopping point of the train. To achieve the requested tolerances for the positioning of a PSD wall, all brackets need to be adjustable in all 3 axes. All screws have to be fixed and checked in compliance with the applicable safety regulations. Based on the brackets, all structural elements can be installed and fixed according to the modular construction system, starting with pre-assembled pillars, followed by threshold elements, and finally the header of a module. The alignment of the threshold reflects the precision and quality of the installed structural PSD wall elements. The installation of the header boxes demands a professional team with appropriate skill and equipment. After the installation and alignment of the PSD wall structure, including threshold and header boxes, all doors can be easily installed according to the plug-in principle. Installed sliding and swing doors are always immediately checked for mechanical functionality. In parallel to the ongoing installation of screen elements, the electrical installation team already installs the control and monitoring systems, as well as the power supply systems for the PSD wall and its related subsystems. Cable ducts guide and protect the cabling between the systems in the technical room and its connected control units on the platform. The outcome of the installation phase includes the installed PSD wall system and its related subsystems on platforms at City and Odenplan stations, and the required site acceptance test reports. To prevent any damages or malfunctions of the installed PSD components before the power supply is activated on any part of the system, different site acceptance tests have to already be performed during the installation works. During the testing and commissioning phase, the conformity of the complete PSD system in terms of safety and fulfillment of requirements has to be tested and verified. The interaction of complex human-machine interfaces demands extensive operational tests within a reasonable time. The functionality of the system within its tolerances in terms of train stopping position, type and configuration of train is tested directly by the customer. To eliminate any unexpected interruptions or failures, it is very important to run full-scale tests with the complete transportation system of the City Line. The results out of such integration tests have always been analyzed in close cooperation with the customer. With the receipt of the final inspection report from the customer, Gilgen could finalize on time by the end of 2016 the handing over of the PSD systems at City and Odenplan stations. The first 6 months of non-public operation have been focusing on the harmonization of the PSD wall system and its related subsystems and the on-site training of operation and maintenance staff. In June 2016, Gilgen was awarded to maintain the complete PSD wall systems with its related subsystems for the next 5 years. To assure safety and comfort for passengers on platforms at City and Odenplan stations, Gilgen provides a 24/7 on-call service for corrective maintenance. The PSD system designed by Gilgen is very easy to maintain. Preventive maintenance works is limited to non-traffic hours and contains, besides cleaning, regular visual and functional checks. Running and stored operating data for all functions can be monitored quickly and easily. Therefore, occurring functional errors during traffic operation can be very quickly located, isolated, and fixed. July 9th, 2017. What a day! Public opening of the City Line. One of Sweden's largest and most important construction projects has been finalized, absolutely on time, also thanks to Gilgen door systems. With the successful start of operation of the City Line in Stockholm on July 10th, 2017, Gilgen Door Systems has proven once more their competencies in the field of platform screen doors. With their more than 25 years of experience in the field of PSD systems and their highly motivated international crew of staff members, Gilgen Door Systems is your reliable partner for realizing PSD full and half-height projects all over the world.